Hello, statistics and pre-calculus. Last time you took an equation and graphed it. Now we're taking a graph and finding an equation for it. Step 1, what is the parent function? I'm looking at this graph. This is an absolute value graph. So my parent function, y equals the absolute value of x. Normally, the absolute value would have a vertex at 0, 0. And here we have the vertex at the point x is 5, y is -2. So that's asking me, how did this change? Well, it went to the right 5, that's in purple, because that matches the equation. Right 5, so that says h equals 5, and down 2, so that says k is -2. Next question is, what's the dilation? In normal absolute value function, the parent function, you would go 1 unit to the left, 1 unit to the right, and up 1. And that's exactly what we have going on here. 1 unit to the left, up 1, 1 unit to the right, up 1. So there is no dilation. So a and b in the equation are 1. None. A equals 1 and b equals 1. So now we've got all the parameters. We just have to write the equation. Y minus k is -2 divided by 1. Now here's the thing. You don't really need to divide by 1. Dividing by 1 isn't going to change anything. So I'm going to take that away just for simplicity. Equals. The function is absolute value function. So we have an absolute value, and we're taking the absolute value of x minus 5 is h, and divided by 1 again. And again, I could write divide by 1, but that gets redundant and unnecessary, so divide by 1, so don't need to divide by 1. We can simplify this if you prefer. Y plus 2 is the absolute value of x minus 5. That's a lovely way to do it. If you prefer the other format, we can use y equals, a is 1, and so 1 times f, it makes no difference. Absolute value, 1 over 1, again makes no difference. So x minus 5 divided by 1 plus k, and k is -2. So it's plus a -2, or you could think of it as -2. So you notice that we have the same equation on both sides, just written slightly differently. You can choose the method you prefer. Let's move on to the next one. From the graph to the equation, what is the parent function? Pause for 10 seconds or whatever it takes you to figure out what the parent function is. Okay, now you've known that parent function is, I hope you wrote, y equals x cubed. That's the shape of y equals x cubed. How is it translated? Y equals x cubed would normally go through 0, 0, and 1, 1, and -1, -1. So 0, 0 is that key inflection point in this case. So 0, 0 has moved 5 to the left. So that's my h. My h is left 5. So h equals -5. It has not moved up or down, so that says k is 0. It has not moved up or down at all. Now, we're looking at these points from -5 to the next point. When we're finding our dilation, normally on your cubic parent function, you would go 1 to the left, 1 to the right, and then up 1, down 1. And this case, we went 3 to the left and right, and up 1 and down 1. So that means we've dilated it in the horizontal direction. We've dilated the x's by a factor of 3. Horizontally by a factor of 3. Vertically, it's still up and down 1, which is what it was. So vertically by 1. So now we have all our parameters. Let's write the equation. Y minus k is 0, so y minus 0. It's not going to be a huge important thing. Divided by a is 1, equals the function. In this case, the function is cubed. So we're going to take whatever we've got and cube it, and we have x minus, my h is -5, so x minus -5 over my b is 3. So there we have it. That -5 is kind of written very unpleasantly, but we can clean this up a little bit. We have y equals x plus 5 over 3 cubed, and that is the graph of the equation. Again, if you prefer this version, we could call it y equals a is 1, function is cubed, we have 1 over 3 times x minus h, and x minus -5, same as x plus 5. And that is cubed. Plus k is 0, so plus 0, don't really need to add plus 0. You see that it's an equivalent equation written slightly differently. Whichever version you like, whichever path you like to take to get there is okay. You make your choice. Thanks very much.